Welcome to percentage increase and decrease. So I want you to imagine for a second, you go to a restaurant and you spend $20. That's the cost of your meal. And of course, you want to appreciate the service at this restaurant, so you leave a good tip, a 20% tip. That's $4, which means the total amount that you spend at the restaurant is $24. Now we can think about this situation using percents. The total or original cost of your meal, well, that's 100%. The original is always 100%. It's like the whole. The tip was 20%. And together, both of these things, you know that you're going to end up paying 120% of that original $20. In fact, 120%, 1.2 of 20 times 20 is equal to 24. And this is what we want to realize today. We want to find some different ways to find the amount of the new, or maybe the amount of the original, and sometimes the amount of the increase or decrease. Let's look at some more examples. So on your paper, we're going to start out with original, part, and new tables. This is an extremely helpful way of organizing the information in a percentage problem. Here's what I mean. If we have a 35% discount, well, let's remind ourselves that a discount is a decrease. What's happening is we're going to take the original and we're going to subtract 35% of it. That's the part that we're subtracting. What we're left with is going to be 65%. Because 100 minus 35 is 65. See how it works? If you have a tax that's 10%, well, that's an increase. So we're going to take 100%, we're going to add 10%, which means what we end up paying is 110%. What do you think the third one's going to be? Oh, just like the one we did. A 20% tip is an increase. 100% plus 20% is 120%. Whenever you have a percentage change problem where it's increasing or decreases, make an original part new table because it helps you to organize the information. Let's look at an example with some real numbers. Devin wants to purchase a jacket which normally costs $200, but it's on sale for 15% off. How much does he pay for the jacket? Okay, reading is so important here. He wants to purchase a jacket which normally costs $200. That's the original. But it's on sale for 15% off. Okay, 15% off, that's a decrease. And that's the part. That's what we're taking away. And we want to find out how much he pays for the jacket. That's the new. Okay, let's fill in the original part new table. And I made one here for you. So the original is always 100%. Easy. The part is 15%. And we need to remember that it's a decrease. So we're going to subtract 15%. Which means that what we have left, the new, is going to be 85%. Already you have more information about this problem. Now we need to put the 200 in the right place. It's the original, so it goes right here. Okay, so now we need to figure out how much he pays for the jacket. Our goal is to get to this square, but there are two different ways we can do it. I want to show you both of them. For each of these, we need to remind ourselves that in percentage problems, the percent times the original or whole is going to be equal to the part or the new. Percent of something tells us that part. So in this case, if we want to find 15% of 200, we're going to change that percent to a decimal, 0.15. We're going to multiply by 200, and we're going to get the part. In fact, that part is 30. 30 is not our final answer because we need the new. So just like we subtracted 15 from 100 to get this, we need to subtract 30 from 200 to get this. So 200 minus 30 is $170. And that's the cost. Now this way works well. You have to do it in 2 steps. There's another way. Maybe you've already figured out this way. Maybe from the table you could see a way that we could get directly to this square. So your second strategy, which we'll do on the other side, is to say what we want to do is take the percentage of the original that we don't want to pay. Because the percent times the original is also going to be equal to the new. 85% of 200 will give us this. 0.85 times 200 is equal to 170. So no matter what, you get the same answer. Both of these are the same. You can do it the same way, but depending on the problem, you might want to do it in one step, or you might want to be able to show how much the discount was and how much the final. That's up to you. All right, let's look at another one. And for this one, I'm going to go to the more efficient strategy of doing it in one step. Lily spends Saturday with her mom. Their bill at lunch comes to $40. Cindy's mom, should be Lily, pays the waiter a 15% gratuity. What is the total amount they spend on lunch? Okay, remember reading is so important here. So their bill at lunch comes to $40. That's their original bill. It's the whole bill. She pays a 15% gratuity. Gratuity is a tip. That means this is increasing, and that's the part. We want to find the new. That's what we're looking for. Okay, let's make an original part new table. Here's a quick way to do it, kind of like tic-tac-toe. Original part new. 100% is always the original. 15% is the part. And don't write 85 here because this is an increase. So we need to add these two together. 115%. Okay, now the 40 goes with the original. And we're looking for the new. So I like to put an X there because that's what we're trying to find. Now, all we need to do is 115% of 40 to get X. A percent times the original is going to be equal to the new. And the percent as a decimal, 115%, don't write 0.115, it's 1.15 times 40 is equal to the new. All right. Pull out my calculator for this. 1.15 times 40 is 46. And I do want to ask myself, is that a reasonable answer? $46? Yeah, totally it's reasonable because she spent 40 and she would have added a $6 tip and 46 is how much total she pays. Great. All right, one more problem, and this one is a little bit tricky. Something different is happening here. See if you can catch it. Miss Neal purchased a new jacket. With a 20% off coupon, she only paid $120. She lost her receipt and doesn't remember the price of the jacket before the discount. Help her find it. All right, do you see what's different here? Well, we've got a 20% off coupon, so that's a decrease. And that's the part. But she only paid $120, and we're looking for before the discount. That's right. This is the new, and we don't know the original. So even though this is a different kind of problem, we're still going to use the same strategy. Let's make an original part new table. Tic-tac-toe. Original, part, and new. 100%. 20% off, which means 80% is what's left. And now she only paid 120, that's the new, so it needs to go here. And my X is with the original, it goes there. Now you might see what to do, but if you don't, let's go back to percent times the original is equal to the new, and plug in what we know. The percent is 80, so that's 0.8. The original is X. We don't know that. And that is all equal to 120. What this is saying is 80% of some number is 120, and we want to figure out that number. And to solve this, all we need to do is some algebra. I'm going to divide both sides by 0.8. And for this work, if you want to use a calculator, that's totally fine. If you want to do it over to the side, also fine. I get 150. Now, before I finalize that answer, I'm just going to ask myself, does 150 make sense here? Would it make sense that she bought a jacket for 120 and that was the price after the discount? Yeah, totally. If this is 150, that's a greater price than the price after the discount. So that means that our answer is totally reasonable. Okay, as you're working through these problems, every single time, make a original part new table. This is your key to success because it helps you to organize the information, and then once you've got it organized, all you have to do is set up the equation based on what you know. Good luck, and yeah, keep doing those percents.